This is our very last lesson in Mod 7, Unit 1. In this lesson, we're going to do some application problems, and we're going to get quadratic equations. We're going to use the skills from the previous lesson to solve quadratic equations by factoring, and then we're going to make sure that they make sense within the context of this problem. Okay, let's see what we've got. It says the perimeter means distance around, of the quadrilateral is a four-sided figure, is 40 centimeters. Find the length of each side. Okay, well, let's see what we've got. Perimeter. Well, there are four sides. So blank plus blank plus blank plus blank have to add up to be 40. What are my sides? Start anywhere you want, it doesn't matter. X plus 2, x plus 5, x squared minus 3x, and 3x minus 2. Those are your four sides, and their lengths have to add up to be 40. I have many like terms. I'm going to get rid of those little lines. I have just x plus 2 plus x plus 5 plus x squared minus 3x plus 3x minus 2 is 40. I'm going to combine like terms over here on the left, and I'm going to put the x squared first. X's. I have this one, this one, this one, and this one. X and x is 2x, minus 3 is negative 1, plus 3 is back up to 2. Something you could say is these cancel each other out, and all I have is 2x. I have this constant, and this constant on the left-hand side. 2 and 5 is 7, minus 2 is back to 5. And this is equal to 40. This is a quadratic equation. It is not equal to 0 yet. I need to subtract 40, or some people might say move it to the other side. And I have x squared plus 2x minus 35 is equal to 0. Now I need to use my factoring skills to see if I can factor this. Is there a greatest common factor in all those terms? No. This is a trinomial, so trial and error. Last sign is negative. That means one of each. I know I need an x and an x to get the x squared. 35. It's either 1 and 35 or 5 and 7. Because these have different signs, they have to have a difference of 2. 7 and 5 have a difference of 2. I'll make it be a positive 7 and a negative 5. You can check your outers and inners, and those work fine. Now use the zero factor property. X plus 7 equals 0, or x minus 5 equals 0. Subtract 7. X is negative 7, or add 5. X is 5. Now I've not finished this problem. The instructions said, my goodness, sorry, find the length of each side. Well, I have two different possibilities for x. So let's give ourselves a little bit more room. The first one that I have to figure out is what would the length of x plus 2 be based on the x's that I have. So I have x plus 2. I have x is negative 7, and I have x is 5. This is getting a little messy. I'm so sorry. In fact, I'm going to clean it up because that's embarrassing. So I have x plus 2. And I'll just do this. If x is negative 7, that's negative 7 plus 2. I put that in the place of x, which is negative 5. Uh-oh. Can the length of the side of a shape be negative? The answer is no. I'm not even going to go any further with this because I can't have a length that is negative. I can have a negative number as a number, but I can't have a negative length. So now let's go over to this one. I'm still trying to find out x plus 2. So x plus 2, in the place of x, I'll put 5. So 5 plus 2, which is 7. That's an acceptable answer. I'll put in 7. I won't check with this one anymore because it's already made something that's impossible. All right, now I need x plus 5. Forget about this one. So x is 5. So it's 5 plus 5, which is 10. So remember, for this one I put in 5, I got 7. For this I put in 5, I got 10. For this one, I'm going to put 5 in 2 different places. I'm supposed to figure out x squared minus 3x. So that's going to be 5 squared minus 3 times 5. That's 25 minus 15, which is another 10. And then finally, the last side that I'm supposed to work on is 3x minus 2. If x is 5, it is 3 times 5 minus 2, which is 15 minus 2, or 13. Now, in this problem, although I got 2 values for x, the problem never said, what is x? The problem said, what are the lengths of the sides? Once I plugged in negative 7 and got a negative length, that's impossible. I threw that answer away and I'm not going to proceed with it. For the other one, I put in 5 everywhere there was an x and I calculated my sides. Okay, let's look at another problem. That one was lots of fun. All right. Number 2. The area of a parallelogram is 95 square miles. Find its base and its height. The formula for area, base times height, is the area. What is the base? In my picture, it is x plus 7. What is the height? In my picture, it's x minus 7. What is the area? They tell me it's 95. All right. Now, this, you might be starting to celebrate and say, well, great, I don't have to factor this. It's already factored. There's a problem. It's not equal to 0. I'm going to have to multiply this out and then subtract the 95. So it is not a gift when they give it to you in factored form unless it's equal to 0. So let's use FOIL. This is a sum and difference product. Product of the first is x squared. The outer product is negative 7x. The inner is positive 7x. Those cancel. Product of the last is minus 49. And that equals 95. Still not in good shape because I need it to equal 0. So I'll subtract 95. Now I only have to get equations equal to 0 when they're quadratic, when they have x squared. So I have x squared minus 144 is equal to 0. Quadratic equation equal to 0. Can I factor that? It doesn't have a GCF. It's a binomial. Is it the difference of squares? Yes, it is. 1 plus, 1 minus. Square root of x squared is x. Square root of 144 is 12. The zero factor property says that either x plus 12 is 0 or x minus 12 is equal to 0. Subtract 12. X is negative 12. Add 12. X is positive 12. Have I finished the problem? No. Once again, this is a geometry problem, and it wants me to figure out the lengths of the base and the height. So the base, it's x plus 7. All right, base is x plus 7. If I plug in negative 12, what's going to happen? It's negative 12 plus 7, which is negative 5. Uh-oh. That blows up. You cannot have a negative physical length. What if x is positive 12? Whoops. That's 12 plus 7, which is 19. The base is 19. The height, I'm not going to use the negative 12 because it messed up with the base. I don't have to go any further with it. All right, the height is x minus 7. So it's 12 from right here minus 7, which is 5. Once again, x can be negative 12, but it cannot be negative 12 and give me valid base or height. So sometimes we throw numbers away because they cannot be realistic in our application problems. Okay, we have one more. It's a little bit different. It's not a geometry problem, and it's a flyaway problem. Sorry, no, I just lost it. There it is. All right, an object is thrown upward from the top of a 160-foot building with an initial velocity of 144 feet per second. The height h of the object after t seconds is given by the quadratic equation. Now, all of that is physics, which results in this equation. You are not responsible for being able to come up with this formula. This will always be given. So the height of the object is negative 16t squared plus 144t plus 160. If you tell me how many seconds have passed, we can plug it in and find out what the height of the object would be. And what does it do? When you throw it up in the air, here's your building, you throw it up in the air, it reaches some maximum height, and then it turns around, and it should have been a straight line, and it hits the ground. So it goes up and comes back down. It says, when will the object hit the ground? Now, h is its height. Its height starts at 160. It increases. Then the height begins to decrease. What is the height when it hits the ground? The height is 0 when it hits the ground. That's very nice. I like that number 0, especially when I'm talking about a quadratic equation. This is a quadratic equation, and it's equal to 0. So let me see if I can factor it. Oh, I have a leading coefficient, which is negative. We know from our very first lesson that we're going to need to factor that out. And it turns out that 16 does go into all of those. I'm going to grab my calculator. I'm pretty sure it does. If I divide this one by negative 16, that will give me t squared. And if I divide this one by negative 16, I will get negative 9t. And if I divide this one by negative 16, I will get negative 10. Let me see if I can continue with my factoring. I have 0 is equal to negative 16 times, and looks like maybe trial and error. The last sign is negative. That means 1 plus and 1 minus. There's my t and my t. I'm sorry, t's looking like plus signs. 10. It's either 1 times 10 or 2 times 5. The difference needs to be 9. That means it's 1 and 10. The big one needs to be negative. So there's 10, there's 1. All right, I've got my factors. It's equal to 0. Now, if the product of these is 0, then negative 16 is 0, or t plus 1 is 0, or t minus 10 is 0. Now here is a little bit of nonsense again. Negative 16 cannot be equal to 0. It's not an unknown. Negative 16 is not the reason that this product is equal to 0. This times this times this equals 0 means something had to be 0. It's not this one. Negative 16 is negative 16. So let's subtract 1 and get t is either negative 1 or add the 10. T is 10. T stands for time. Could this object hit the ground negative 1 seconds ago? No. Time can't be negative in our world either. Perhaps in the world of Einstein and relativity and time travel, it could be, but not in our little world right now. So our only answer is that it will hit the ground in 10 seconds. I had 3 factors. The first one was a constant. It in no way can equal 0. It is not part of the solution. The second answer, because it was time, time can't be negative. Distances can't be negative. If this were just about numbers, numbers could be negative. But the only legitimate answer is that time, it would be 10 seconds. All right, you got 3 application problems. Take a look at them in your homework.